Değerli akademisyenler, öğrencilerimiz hoş geldiniz. Müsaadelerinizle İngilizce olarak sunumu arz etmek isterim. Good morning, distinguished participants and audiences, because there are a lot of people, they could not join us. They are watching this presentation in the internet possibilities. The opening ceremony session will take the opening speeches and two keynote lectures. Until 12:30, we would like to execute this session. Before the speeches, I would like to invite you one moment of silence in the memory of human loss during marine casualties and their works in seas and the martyrs. Then we will listen Turkish national anthem together. Thank you very, very much. I would like to give a brief speech for the opening of the second International Congress on Ship and Marine Technology. Esteemed participants, dear guests from academia and industry, dear students, audiences, and all watching us. Thank you very, very much for your attendance and participation. First, I would like to thank the team who organized the Congress. The owner of the Congress is the Turkish Chamber of Naval Architects and Marine Engineers. The organizers, the organizing persons and institutions are from the following universities. These are organizing institutions and their representatives. We all work together. Bursa Technical University, Bandırma 17 Eylül University, Turkish Naval Academy of National Defense University, Middle East Technical University, University of Lisbon, Portugal, Strathclyde University, Glasgow, UK, and Newcastle University, Glasgow, UK. The last is our university, Yıldız Technical University. I think I have forgotten. My name is Professor Ahmet Dursun Alkan, Congress Chairman and at the same time full-time academic staff at Yıldız Technical University. Green energy, climate change or climate crisis, global warming, environmental degradations are the critical issues always we discuss in every place. Of course, there are a huge amount of studies, published materials, and programs on these vital issues. There are big efforts, of course. The countries, IMO and the European Commission try to define ambitious strategies to decrease harmful emissions, to mitigate climate change and global warming. The European Commission in the Transport 2050 their roadmap, they declare the following information. By 2030, 30% of road freight over 300 kilometers should shift to other modes, such as rail or waterborne transport, if it is available, waterborne transport. The modes of the transportation they try to move to rail and maritime. And the target is more than 50 by 2050. The strategy of the European Commission in 2050, Transport 2050 they call, for a competitive transport system, they set ambitious goals also to cut 60% of carbon emissions in transport by 2050, the year 2050. The maritime key goal is at least 40% cut in shipping emissions. IMO adopted key short-term measures aimed at cutting the carbon intensity of all ships by at least 40% by 2030. May I draw your attention now to another issue? We are widely familiar with hydrogen as fuel or energy carrier, hydrogen element, hydrogen gas. But hydrogen is feedstock, raw material, which will be used to synthesize many other chemicals and fuels for many purposes to be used in various sectors. More clean electricity capacity to fuel the hydrogen production is under work. Researchers claim that all these efforts will help change the carbon fuel economy to the hydrogen fuel economy. Actually, petroleum sector turns their face to renewables and hydrogen. As a result of these initiatives, the actors will absolutely further power their global competitiveness. There is a big competitiveness in energy sector, fuel sector. Energy is needed for all the production, for all energy, food and water. These are three critical elements, critical areas under the umbrella of course, environmental constraints are always valid, exist. We should effectively use energy, water, and food and their production as well. As regards to renewable energy, I should say that with the organizing committee, we have studied which subjects we should address in the opening speech, during the opening speech. So they also gave me interesting feedback on renewable energy, which one of them is wind energy. As regards to renewable energy potential and capability, I would like to give a local example from Turkey. Renewable Wind Europe, it is an institution, it is a body, prestigious body. Their data states that Turkey has rapidly developed into a leading market for wind energy. There are 3,560 companies are currently active in the Turkish wind energy sector, directly or indirectly employment of 25,000 people. All onshore, not offshore. But offshore wind development might also be around the corner, they state. Offshore wind. There are papers in our Congress as well dealing with wind energy, offshore wind energy. I suggest you to follow those presentations. Recently, the IMO has introduced the Attained Energy Efficiency Existing Ship Index, which is EEXI. It followed the EEDI, Previous Energy Efficiency Design Index, which was the previous one was only for new constructed ships. But now the coverage area is larger. They include existing ships. Energy efficiency regulations directly demonstrate the importance and the necessity of green and intelligent maritime solutions, thus research and innovation. The regulations direct us to research, technology, innovation, protecting the environment as a constraint, of course. Marine equipment industry, marine equipment industry. So manufacturing, mechanical, electrical, and electronic equipments, novel materials, and supplying lifetime services, satisfying required standards and certificates, strengthen domestic, maritime, and employment, skillful employment workforce. Another subject is maritime education and training. Maritime education and training are always in the top agenda, which requires well-established cooperations among the institutions and IMO. Still much effort to do on maritime education and training. As the command of the organizing committee, I state another issue, which is shipwrecks, archaeological shipwrecks. They consist dangerous materials inside. There are thousands of shipwrecks underwater. For the environment, very, very risky. There are fish nets. They trap the fishes, so it harms also the biological life in sea. This is a critical issue. Cyber attacks. This issue needs careful approaches and measures and human diagnostics and decisions. Cyber attacks, which is very critical. Autonomous transportation. Autonomous transportation and its environmental impacts in domestic welfare, economy, will be interesting. Autonomous, remote operated vessels, so on, they are in development, offer very big competition, worldwide competition. Women in maritime, IMO's genders program states IMO continues to support the participation of women in both shore-based and seagoing posts. I remember very well, some years ago, there was a Norwegian professor gave us a seminar in Istanbul. He said 45% of maritime students in Norway, including engineering in Norway, they are female. So 45% students are female in Norway. This is quite interesting. Before passing to the opening speeches of our stakeholders, I thank again, in my last words, I thank again all participants, all audiences watching us, and we thank a lot to the participating persons and institutions, industry experts who strongly supported this Congress by participating in the sessions. There are two types of sessions during our Congress. First, first group are special sessions. There are industry and academicians and expert persons speaking there. In the afternoon, there will be shipbuilding, innovation in shipbuilding, a special session, and following that, another one will be held in the wave tank or YTU, Yıldız Technical University's Hydrodynamic Research Laboratory in our Davut Paşa campus. It will be interesting. There are interesting experimental studies will be presented. Tomorrow there are also special sessions, but in these 3 days, 16th, 17th, and 18th of September, there are paper presentations, scientific paper presentations. The time period for the presentations are a little limited. We hope to convey the questions asked to the papers, maybe not during the presentation, but later. We hope to increase the impact, the interaction of the conference. We take care on this. My colleague, before my presentation, my colleague here told me that in this hall of the auditorium hall of the university, we use 100% of fresh air, all COVID-19 measures are taken. They work a lot. I thank them on behalf of you. I think it is better to listen the other speakers, paper presentations, and the other speakers. I thank you very, very, very much for your attention. First speech will be delivered by Mr. Salih Bostancı, Chairman of the Turkish Chamber of Naval Architects and Marine Engineers. The floor is yours.
Hocam müsaadenizle ben bir klasik açılış yapmak istiyorum. Sayın Dekanım, Sayın Deniz Tiyatrosu Meclis Başkanım, Sayın Gemi Makineleri İşletme Odası Başkanım, Sayın Deniz Tiyatrosu Yönetim Kurulu üyem, Sayın akademisyenler, öğrencilerimiz, sevgili dinleyenler, hepiniz 2. Gemi ve Deniz Teknolojisi Uluslararası Kongremize hoş geldiniz. Biraz Gemi Mühendisleri Odası'ndan bahsetmek istiyorum sizlere. Bugüne kadar mesleğimize ve denizcilik sektörüne katkısı olan tüm hocalarımızı rahmet ve minnetle anmak istiyorum başlamadan önce. Gemi Mühendisleri Odamız 11 Aralık 1954 yılında kurulan ilk mühendislik meslek odasıdır. İlk olmanın şeyiyle özellikle denizcilik endüstrinde önemli adımlar atmıştır. Bunlardan birkaç tanesini sizlerle paylaşmak istiyorum. Odanın kurulmasından hemen 1 yıl sonra Deniz Mecmuası isimli 1955 yılından beri yayınlanan, şu anki ismi Gemi ve Deniz Teknolojisi olan dergimizi çıkartmaktadır. Dergimizin 219. sayısı yayınlandı. Dergimiz ulusal akreditasyon alarak şu anda uluslararası boyuta çıkartmak için çalışmalar devam ediyor. Odamız sektörün gelişmesi için bilimsel çalışmalarına kongremizde devam etti. 1968 yılında bu kongrenin ilki yapıldı. 1968 yılından beri 10 tane ulusal Teknik Kongre adı altında gerçekleşti. 2016 yılında ise bunu biz uluslararası boyuta çıkartmamız gerektiğini düşünerek uluslararası boyuta taşıdık. Birincisini 2016 yılında gerçekleştirdik. Bugün de ikincisini gerçekleştirmenin mutluluğunu yaşıyoruz. Kongremize 79 tane bildiri geldi. Yanlış bilmiyorsam son olarak. 199 tane konuşmacı bu bildirileri bizden sonraki açılıştan sonra devam edecekler, sunacaklardır. Bu da bizim için bir mutluluk kaynağı teşkil ediyor. Hepimizin bildiği son zamanlarda IMO'nun bala suyu regülasyonu ve NOx sülfür regülasyonlar devreye girdi ve bununla işte denizcilik sektörünün çevreye duyarlı hale getirilmesi için başta Amerika ve ABD, başta Amerika ve Avrupa Birliği bu konuda ciddi uygulamalara geçiyor. Bunun sonucu olarak da denizcilik endüstri buna doğru ilerliyor. Pandemi zamanında birçok hayatımıza olumsuzluk girdi ama pandeminin olumlu yanları şunu gösterdi bize. Denizcilik sektörü olmadan dünya yaşayamaz. Bütün herkes durdu, evine kapandı ama denizcilik sektörü, taşımacılık bir şekilde devam etti. Bu da bizim için olumlu yanı. Pandemiyle birlikte şunu da öğrenmiş olduk. Dijitalleşme ciddi bir hızlı ivmelendi. Önceden hep bunları konuşuyorduk, Endüstri 5.0 şeylerini. Ama pandemi sonrasında bu süreç 2 kat, 3 kat belki hızlanmış oldu. Bizim de sektör olarak buna hızlı bir şekilde adapte olmamız gerekiyor. Bu tip kongreleri daha sık yapma ve sektörümüzü dijital dönüşüme hazırlama ve burada yaşanacak sorunları çözmek için daha çok bir araya gelmemiz gerektiğini düşünüyorum. Dünya üzerinde yaşayan insanlar olarak bizim ciddi sorumluluğumuz olduğunu düşünüyorum. Bu da şöyle, biz hayatımızı kolaylaştırmak için teknoloji ve ürünler üretiyoruz. Hayatın her alanında. Bunu üretirken de çevreye duyarlı olmasını daha önceden dikkat edilmiyordu. Şimdi buna fark edip işte duyarlı olması için ciddi kurallar ve kaideler geliyor. Şu anda da bütün herkes bununla alakalı çalışmalar yapıyor. Yaşam boyu döngü olsun, işte karbon ayak izinin olsun, işte bu ballast water ve scrubber şeyleri olsun. Bu temelde çıkarak da kongremizi bu sene temasını yeşil ve akıllı deniz endüstrisi olarak belirledik. Özellikle bunu seçtik. Buna hazırlanıp sektörümüzün adapte olması için en azından buradan çözüm önerileri çıkacağını düşünüyoruz. Biz Gemi Mühendisleri Odası olarak denizcilik ve gemi sektörünün bilimsel tabanlı gelişmesini istiyoruz. Bu yönde de çalışmalarımız devam ediyor. Bugüne kadar hep destek verdik. Bundan sonra destek vereceğimizi ifade etmek istiyorum. Kongremizde düzenlenmesinde emeği geçen başta Ahmet hocamıza ve düzenleme komitesine, bu kongreye destek veren yönetim kurulu arkadaşlarıma, çalışanlarımıza, bildiri sunan katılımcılara teşekkürlerimi sunuyorum. Kongremizin hayırlı ve uğurlu olmasını diliyorum. Hepinizi saygı ve sevgiyle selamlıyorum. Kısa bir İngilizce olarak yabancı misafirlerimize de seslenmek istiyorum. Birkaç kelime müsaadenizle. Good morning participants. Welcome to Second International Ship and Maritime Technology. The Congress mainly focus on the shipbuilding, green and intelligent maritime technology topics in order to decrease pollution at the sea, increase the efficiency of the vessel at the maritime target and the academic developments. The Congress will key maritime sector, academics and the university all around the world which have a big influence in the industry. I would like to thank you to everyone that participants our Congress and sent articles and support us. Especially I would like also thank the organization committee and Professor Mr. Ahmet Dursun Alkan in your presence. I wish you successful and beneficial Congress for all of us. Thank you.
Thank you very much for your interesting speech. Now I would like to invite Mr. Basharan Bayrak, who is board member of the Turkish Chamber of Shipping.
Teşekkür ederim hocam. Sayın Dekanım, Sayın Dekanlarım, Sayın Denizciler Odası Meclis Başkanım, Gemi Mühendisleri Odası Başkanım, Gemi Makine Mühendisleri Odası Başkanım, değerli hocalarım, değerli öğrenciler, hepinizi Deniz Ticaret Odası yönetim adına saygıyla selamlıyorum. Gemi Mühendisleri Odası tarafından Yeşil ve Akıllı Denizcilik Enstitüsü ana teması ile ikincisi düzenlenen Uluslararası Gemi ve Deniz Teknolojisi Kongresi'nin açılışında sizlerle birlikte olmaktan onur duyuyor. Hepinizi saygıyla selamlıyorum. İklim değişikliği tehdidinin küresel ekonomi politikalarını, uluslararası ticaretin kurallarını, ürün standartlarını hızla değiştirmeye başladığı bir dönemde bu kongre gerçekten çok önemli bir konuyu gündeme taşımaktadır. 2 gün sürecek kongrede sunulacak bilimsel tebliğlerin bu değişimden en çok etkilenecek sektörlerin başına gelen denizcilik sektörüne yeni bir vizyon sağlayacağını ve ufkunun açılmasına vesile olacağına dair inancım tam. Değerli Hazirun, günümüzde teknoloji akıl almaz bir hızla gelişmekte. Dünya neredeyse her sabah yepyeni bir buluşla gelişmelere başlıyor. Artık 20. yüzyılda yeni buluşların ve teknolojilerin ortaya çıkmasına bağlı olarak daha hızlı, daha verimli ve deniz çevresinin sürdürülebilir bir şekilde korunduğu bir hizmet sunabilmek için teknolojik dönüşümün benimsenmesi ve uygulanması denizcilik sektörünün içinde zorunlu hale gelmiş bulunmaktadır. Ülkeler enerji verimliliğini artırıp çevre güvenliğine katkı sağlayacak yeni arayışlar, yeni buluşlar peşinde koşacaklardır. 2018 yılında IMO'da küresel ısınmaya mücadele için hedef konulan 2030 yılı için gemi ton mil başına bazında %40, 2050 yılı için sektör bazında %50 azaltım hedeflerini yetersiz görmeye başlamıştır. 2050 yılında karbon nötr denizcilik sektörü hedefi Deniz Ticaret Odası'nda üyesi olduğu Uluslararası Deniz Ticaret Odası, ICS, Baltık ve Uluslararası Denizcilik Konseyi, BIMCO gibi sektör birlikleri tarafından önerilmektedir. Karbon nötr denizcilik sektörü hedefi için kısa ve orta vade tedbirleri olarak teknolojik gelişmelere yol açacak Ar-Ge, enerji verimliliği ve alternatif yakıt pilot gemi uygulamaları etki analizleri büyük önem taşımaktadır. Avrupa Birliği Yeşil Mutabakat kapsamında Birliğin karbon emisyonlar hedefini 1990 yılına göre 2030 yılı ile %55, 2050 yılı ile %90 azaltım olarak belirlemiştir. Bu amaçla Avrupa Birliği 2030 yılı ile sıfır emisyonlu gemi tasarımlarını tamamlayarak inşaatlarına başlanmasını da sürdürülebilir ve akıllı ulaşım stratejisi içerisinde benimsemiş bulunmaktadır. Kısa dönem enerji verimliliği tedbirleri olarak geliştirilen bu yeni gemi form pervane, dak, fin, dümen uygulamaları, yüzey sürtünme azaltıcı boya, hava yağlama ve güneş ve rüzgar enerjisini yenilebilir enerji olarak gemilerde kullanımını gemi teknolojisinde gelişmeler izlemektedir. Ancak armatörler gemi enerji verimliliği endeksi, karbon yoğunluk göstergesi, CII, karbon ve yeni kurallara uyum sağlamaya yönelik olarak bu tedbirlerin mevcut gemilere de uygulanmasına hangi tedbirlerin hangi gemilere uygun olduğu konusunda açıklık getirmesi beklenmektedir. Bilgi birikimi ve yaygınlaştırılması için pilot uygulamaların yapılması ve Ar-Ge kapsamında desteklenmesi büyük önem arz etmektedir. Alternatif yakıt olarak değerlendirilen LNG, metanol, amonyak, hidrojen ve sentetik yakıtlar gemi makine teknolojisi açısından yeni bir yaklaşıma ihtiyaç duyulması dışında gemide transfer, depolama ve emniyetli seyir gibi konularda gemi mühendisliği çözümlerine ihtiyaç bulunmaktadır. Değerli Hazirun, dünya çevre etkisini en aza indirecek, insan faktörünü büyük ölçüde devreden çıkaracak elektrikli, hibrit, uzaktan kumandalı, insansız gemiler üzerinde çalışılıyor. Ve buna benzer çeşitli araçlar üzerinde, deniz araçları üzerinde çalışmalar devam ediyor. Ülkemiz tersanelerinin ve gemi inşaat sektörünün de bu baş döndürücü yarışta önemli başarılara imza atmasını gururla izlemekteyiz. Bugün tersanelerimizde yabancı alıcılara diğerlerinin yanı sıra LNG yakıtlı hibrit yolcu ve araç ferileri, LNG yakıtlı römorkörler, LNG yakıtlı hidrolik hibrit sevk sistemlerine sahip römorkörler ve uzaktan kumandalı otonom tekneler gibi katma değeri yüksek deniz araçları da üreterek ihraç ediyoruz. Geldiğimiz noktada bu küresel yarışta var olmaya devam edebilmek, kısaca bu örnekleri çoğaltabilmek için akademisyenlerin yöneticisine, mühendisinden işçisine kadar sektörümüzün bütün bileşenleri büyük görevler düşüyor. Elimizden geleni çok daha fazlasını ortaya koymak için çaba harcamamız gerekiyor. Tersanelerimizin gemi tasarımlarının, gemi yan sanayi sektörümüzün bu çerçevede scrubber ve balast suyu arıtma sistemlerinin mevcut gemilere entegre edilmesinden son yıllarda gösterdiği başarıyı, enerji verimliliği artırıcı gemi dönüşümlerinde de tekrarlaması, sıfır emisyonlu gemi tasarımları ile yeni gemi inşaatında söz sahibi olması hedeflenmektedir. Sanayici ile akademisyenin tasarımcıyı buluşturan bu kongrenin de bu yönüyle önemli yararlar sağlayabileceğini ümit ediyoruz. Kongrenin sektörün gelişimine katkısı, rekabet sağlayıcı çözümler, üretme işlevi geleceğin gemi ve deniz araçları pazarında söz sahibi olunabilecek ürünlerin geliştirmesine aracılık etmesi gibi yanları kuşkusuz önemlidir. Bunun yanı sıra kongre ayrıca yaratıcılık ve tasarımın sektör için önemini ve vazgeçilmezliğini ortaya koyması açısından yararlı olacaktır. Kongrenin başarılı geçmesi dileğimle hepinizi tekrar saygıyla selamlıyor. Başarılı bir kongre diliyorum. Teşekkür ederim.
Thank you very much for your detailed and interesting speech, Mr. Başaran Bayrak. Now I would like to invite Captain Salih Zeki Çakır, who is President of the Assembly of the Turkish Chamber of Shipping. The floor is yours.
Teşekkür ederim hocam. Sayın dekanlarım, sayın başkanlar, değerli katılımcılar, hepinizi saygı ve sevgiyle selamlıyorum. Ben de şahsen teknoloji, deniz teknolojileri konudaki çalışmaları elimden geldiğince yakından takip etmeye çalışıyorum. Yıllar boyunca hem fiilen işin içinde hem girişimci olarak ve meslek insanı olarak hem gemide hem işletmelerde hem gemi inşaat sanayindeki gelişmeleri yakından takip ediyoruz. Bu ve benzeri kongrelere elimizden geldiğince katılıp destek olmaya çalışıyoruz. Bu tip kongreler çok önemli. Başaran Bey vurguladı. Önümüzdeki süreçlerde Türk ve dünya denizciliği için yeni teknolojilere bağlı olarak önemli fırsatlar, ama her fırsatın veya her tehditler barındırıyor. Her tehditin de tabii fırsat içerdiği hepimizin malumudur. O anlamda biz girişimciler olarak bu fırsatların ve tehditlerin ne olduğunu, ne olabileceğini iyi anlayıp tedbirler geliştirmemiz için bu tip organizasyonlar çok önemli. Bu anlamda Gemi Mühendisler Odamıza ve katılımcılara destek veren değer paydaşlara Deniz İşler Odası Meclisi olarak, başkanı olarak yürekten teşekkür ediyorum, tebrik ediyorum. Kongrenin hayırlı olmasını, Türk ve dünya denizciliğine hayırlı olmasını diliyorum. Akıllı gemiler, akıllı tersaneler, akıllı limanlar. Biz eskiden sadece akıllı telefonla sınırlıydı bu iş. Şimdi akıllılık her şeye yaygınlaştı. Muhtemelen çok daha fazla başlıkla önümüzdeki süreçte devam edecek. Her teknik konularda, bu tip kongrelerde eskiden daha sınırlı başlık olurdu. Ama zaman geçtikçe daha çok başlıkla muhatap oluyoruz. Yeşil gemi, işte çevrenin korunması, hepsi bunlar ideal ve olması gereken. Fakat bu işin işte bir de bütçe tarafı var. Dünya, yani genelde dünya ama özelinde de Türk denizciliği bu gelişmeleri, bu dönüşümü, bu yenileşmeyi ne derece başaracak hepimizin aslında merak etmesi gereken büyük soruda aslında olması gereken de bu ve buna da hazırlıklı olmalıyız. Değilse tabii süreç bütün bunların olacağı yönünde. Bunun geri dönüşü yok. Kimse eksik teknolojiyle artık taşımacılık sürdürülemez. Fakat buna uygulamaya gelince kim hangi ölçüde, hangi ülke, hangi sanayi ne derece adapte olacak ve kendini hazırlayabilecek veya bu maliyeti ödeyebilecek. Çünkü neticede bu işin ucunda maliyetler var. Tabii bu belli bir süreçte bu dönüşümler yapılacak. Hemen önümüzdeki 5, 10, 20, 30, 50 yılda tabii uzun bir vade ama neticede hepsi ciddi sektöre maliyet getirecek hususlar. Mevcut deniz armatörlerin, gemi inşaat sanayinin önünde ciddi faturalar koyulacak. Bunları karşılayabilecekler, hayat eğitimini devam ettirecek, edemeyenler başka işler yapacak. Sayın Hocam, biz de tabii kendi acımızdan merak ediyoruz bu süreçte kim ne yapacak, Türkiye ne yapacak, dünya ne yapacak. O anlamda bu tip kongreler çok önemli. Tekrar emeği geçenlere teşekkür ediyorum. Hayırlı olsun. Hepinizi sevgi ve saygıyla selamlıyorum.
Your speech was also interesting. I wish I would translate in other languages as other speakers too. Thank you very, very much. The last speaker in video, we will listen him, rector of Yıldız Technical University, who is also the university is also hosting support gives this conference. I would like to introduce Rector of Yıldız Technical University for his speech.
İkinci Gemi ve Teknolojisi Kongresi'nin değerli katılımcıları, sevgili akademisyen arkadaşlarım, değerli araştırmacılar, sevgili öğrenciler, gemi ve denizcilik camiasının tüm paydaşları, tüm bileşenleri sizleri sevgi ve saygıyla selamlıyorum. Değerli arkadaşlar, hepinizin bildiği gibi inovasyonun ve liderliğin başladığı yer gemicilik camiası ve gemicilik dünyasıdır. Bunları hatırlayın. Lütfen tüm uluslararası kuralların geliştirildiği, tüm teknolojinin ilk kullanıldığı bir alandan bahsediyorum. Gemi mühendisleri, gemicilik ve denizcilik camiasının paydaşları aslında bu alana katkı sağlayarak dünyanın gelişimine, insanlığın yararına katkı sağlamışlardır. Bu nedenle bu kongreyi çok önemsiyorum. Emeği geçen herkesi bir kez daha kutluyorum. Değerli arkadaşlar, Yıldız Teknik Üniversitesi Gemi İnşaatı ve Gemi Makineleri Mühendisliği bölümü ve aynı zamanda Gemi Makine İşletme Mühendisliği bölümüyle bir Gemi İnşaatı ve Denizcilik Fakültesi olarak önemli bir boşluğu doldurmakta ve sektöre çok değerli mühendisler yetiştirmektedir. Bunun da haklı gururunu yaşıyorum. Gemi ve Denizcilik Teknolojisi Kongresi'ne ev sahipliği yapmaktan da gurur duyuyorum. Çok istememe rağmen sizlerin arasında maalesef bulunamıyorum. Ama kalbim, beynim, aklım sizlerle beraber. Sizin heyecanınızı paylaşıyorum ve yaptığınız katkılar için hem üniversitem adına, hem sektör adına, hem de bilim dünyası adına sizlere teşekkür ediyorum. Sizleri saygı ve sevgiyle selamlıyorum. Yolunuz açık olsun. Teşekkürler.
Professor Dr. Tamer Yılmaz, Rector of Yıldız Technical University, he gave his speech in video. I hope our technical team is ready to pass to the session of keynote lectures. Everything is all right? Geçebilir miyiz arkadaşlar? Davetli konuşmacılar başlayabilirler mi? Professor Carlos Guedes Soares, hello from Istanbul, Yıldız Technical University. Do you hear me? Do you hear me, Professor? We cannot hear you.
Yes, I hope now it works. I was muted. It is a pleasure to be in contact with you. I have been following the YouTube transmission, which is working very well.
Thank you very much, Professor Carlos Guedes Soares. If I spell well, I studied it. Professor Soares had thousands of publications. For that, I should underline it. When we had written communications 2 months ago, he told me, he explains the fact that it seems that, he says, it seems that I have been lucky with the number of good students and colleagues cooperating with me. His conclusion was that. I think you all know Professor Soares. He's in Portugal, Lisbon. He's from Lisbon Technical University, CENTEC. It is a Center for Naval Architecture and Marine Technology. It is now it is time to listen his keynote lecture. The floor is yours, dear Professor. Please.
Okay, I hope I can share my presentation. And, I have shared my presentation. Are you able to see the slides? Yeah, it seems very well. Well, it is a pleasure to be able to participate in this conference. We have, despite the difficulties that COVID brought to all of us, that have made it difficult to be in close contact, it also brought us quickly to be able to use the digital technology to be together. So then, despite not being able to be physically with you, with these systems, we have the possibility of being in contact. It is a pleasure to be involved here. I have been earlier at Yildiz Technical University. I have also been involved in earlier conferences, and I do recognize the conference hall that we have been showing. So in some sense, at the distance, it's possible to be with you. Well, the topic for today is a topic that is somewhat new to naval architects. This is not the traditional naval architecture discipline, but this represents an area that our profession has been called upon to contribute as we have all the necessary background to work in activities and structures and systems that operate at sea. So as renewable energies have been developing in the offshore, we have been gradually involved in them. And this is in fact one of the areas that we are giving priority in our research center. So I'll be happy to provide you an overview of developments in offshore renewable energy. I will start by covering the scope of the renewable energies, and after presenting the broad view, I will concentrate more on the offshore wind and on the ocean or marine energies. And in particular, I will give some more attention to wave energy and wind energy, which are the ones that we have been devoting more efforts. So the need for renewable energies, it's not necessary to emphasize, and we see that we have different forms of renewable energy that are relevant, and some of them are also relevant to be developed at sea. So we have wind energy, wave, and tidal. They are the forms of energy that have been eventually more explored offshore. It is interesting to mention that solar energy has started to be developed in inland waters, in lakes, and these kind of locations. And research is now ongoing to try to bring them to the offshore. But up to now, these first three are the ones that have been mostly used offshore. So the so-called ocean energy or marine energy has been typically associated with the energy that comes from the sea. So we have the energy associated with tides, and here this is very much associated with lagoons and dams that are filled with the tide, and then with the changing of the tide, different height is used to propel turbines. We have tidal currents, which are the sea currents that are associated with the change of the tides. So this form, it's to use the speed of the currents to propel some propellers. We have the wave energy, which uses the oscillatory motion of the waves to produce motion that then is transformed into electricity. We have salinity gradient, which at special locations can be used, and thermal gradient also that takes advantage of the difference in temperature at surface and at depth, which again, only very special locations are able to do that. So this is what is known as ocean or marine energy. However, an important source of energy, as we will see, is offshore wind, which, although is not produced by the sea, is produced at sea. The wind conditions at sea are more stable and than on shore, and because of less friction with the topography, we get better speeds. So the use of the wind there is more efficient. So we have been using the designation of renewable energy offshore to include the offshore wind and the ocean or marine energies, which is what I will be talking today. So this graph will give you some idea of how the ocean energy is being explored in different countries. This dark blue represents wave energy. The light blue is tidal current. You see that wave energy is present in several countries, and in some of them also tidal current is significant, but it is always smaller than wave energy. And we have OTEC and salinity gradient that are OTEC is very special in India, salinity graded in Mexico. So those are very specific applications of this type of energy. Now, if we see then wind, we see that there has been a very steady growth of the installed wind capacity. The market growth during all this period has been more than 11%. And if we look at the last 10 years, it has been growing at the rate of about 20%, which you can realize it's a very high rate of growth. This is total wind energy, which is dominated by onshore wind energy. We see that the countries that are more important in this producing energy, China has about 35% of the share. There are new installations in Asia, and Europe has typically the second spot, while America is the third one. We have 9 countries that are producing more than 10 gigawatts of energy. These are the 10 countries. You see the percentage share of the different countries. Again, this is total wind and mostly onshore. Now, if we look at the offshore wind capacity, we see here the development that it has had. It has also shown a steady increase over the years. And if we look at the countries in which this wind energy has been developing, we see that Europe has been very much leading in the offshore market. The first offshore wind farm was started in Denmark, Vindeby, a very small one, and since then we have been increasing very much. The costs of wind production have been decreasing very much, and we have been seeing installations of wind farms moving to water depths of over 40 meters at distances up to 100 kilometers from shore. Currently, more than 90% of the installations are in European waters. You can see here that the UK and Germany have a larger share. The first bar here represents the total capacity until 2015, and this is the total capacity. The second one is the total capacity in 2016. So the difference is what has been installed during the year of between 2015 and 2016. We see an important increase in Germany. We see other countries, Denmark, Netherlands, so forth, several European countries here. However, we see that China is also developing this technology, and also Asian countries like Japan and Korea, while the US is slow in developing the offshore wind capabilities. So this gives you an overview that while the onshore wind is very much dominated by Asia and specifically by China, in the offshore, still Europe is dominating the market in exploring the advantages of offshore wind capabilities. Now, let's try to understand why those developments and what is the status of the technology development in the various wind renewable energy sectors. This shows the costs of production of electricity, and this yellow bar, which is somewhat between 5 and 10 cents per kilowatt, represents what non-renewable energy costs. So renewable energy becomes competitive when they manage to produce it at the same cost or even lower. And we see the different types of energy with the bar representing their costs. We see solar energy can be very expensive, but it has also some possibilities of producing energy at affordable cost, which shows its potential for commercialization. Hydropower has very much within the range of the conventional costs. So whenever possible, this has been explored. And now we see the ocean electricity, which it's the ocean or marine energies. Their cost is all above the non-renewable energy. So typically, this is centered on the 20 cents, while here we have under 10 cents. However, wind energy has a capability of producing energy at commercial costs, whereas other, which is probably associated with the offshore component, represents higher costs. So this explains the different stages. This shows that wind energy can be in a commercial phase, whereas ocean energy is still in research and development, hoping to bring down costs so that it can be commercialized. Now, let's look at what is the stage of development of the different forms of energy to understand where we are in the different forms. Typically, the different concepts have to go through different phases. We have a first stage of characterization of the concept, which is then optimized from a technical point of view. And these phases require the verification in laboratory tests. So this corresponds to the technology readiness level between 1 and 3 here, and between 4 in stage 2. After having this technical optimization, we have a move to the third stage, where we do the demonstration in a prototype, in a scaled prototype. So this is basically verification in sea trials. And then we move to the performance assessment of the concept, where we do full-scale demonstration, and finally we move to commercial application. So these are the stages in which each concept has to go through. At present, the fixed bottom wind technology is already in commercial applications. There are several wind farms that have been producing electric energy for the grid in several countries. The floating offshore wind is at an earlier development stage. It is at stage 4, where we have a full-scale prototype demonstration. We have had demonstration of different individual prototypes, and we are now starting the demonstration of wind farms. We have a wind farm started to be installed in Scotland of one type of floating device. Another one is being tested in Portugal. So we have moved from the individual prototype to the wind farm of several prototypes, hopefully being then the final stage before commercial applications. Now, wave energy devices are still at the demonstration stages. There are very few cases where we had concepts going beyond this phase. So we still have some way to go with wave energy devices in this scale of different steps to reach commercialization. All right, now if we start then looking at the third ocean energy that we have referred, this is tidal stream. This tidal stream only becomes economically viable in places where the tidal current has significant speeds. And this is very localized. You see here the areas with the yellow, red, and dark red. This shows areas where this tidal stream has a significant speed to be used for tidal exploration. And you can see also that in some of these locations, like for example in Gibraltar, in the canal, English Canal, these locations are also locations where we have heavy shipping traffic. So despite having good conditions here, the ship traffic makes it difficult to have a widespread use of the area for tidal energy resources. So the development of this industry is more localized, and therefore I will not be covering this very much. Although I need to emphasize that, for example, around UK, where there are several good locations for this energy, this type of devices have been used, and eventually there are even more tidal devices installed than wave devices in this region. But in general, this is not a type of energy that can be used very spread. You see here close to Turkey also, there are locations where the tidal stream can become interesting, but again, these are locations of heavy traffic, so this raises the difficulties that I have just mentioned. So I will concentrate then a bit more the description and then the attention to wave energy and try to provide you an overview of the type of devices and type of technologies that have been used to explore this type of energy. The first step that we have to do is to identify where we have wave power, so where the energy of the waves is high enough to provide good efficiency in its exploration. And you see the colors, the red colors are obviously the high intensity. You see that this coast of Europe is covered with high energy, as well as the coast of the States. The East Coast, the West Coast also has good energy, as well as in Asia. There are an area here that also have high energy. In South America, we have Chile has good conditions here, Australia. So there are some areas where this is a higher potential, and you see some numbers here that indicate the total availability in those ocean areas. So how do we assess the wave energy? Well, initially, the first information that was available was from coastal wave rider buoys that have been measuring waves for the objective of providing the wave climate for coastal engineering. So that was the first type of data that was used to assess the energy. On a second level, then use started to be made of hindcast data or archive met-ocean data that have been produced by global numerical models that normally the meteorological office run. However, this is in a relatively coarse grid, and this is basically for the ocean or the very deep water. The third type of methods used then use this met-ocean data as the starting point or boundary conditions, and then run coastal wave transformation models that transform the propagated deep water waves to coastal areas to assess what would be the wave energy in coastal areas. And finally, the last technology that is being used is to have integrated models which include coastal ocean areas, and then coastal models are nested within these. So predictions are made taking into account the whole ocean that generates swell that often comes to the coast, and also the wind-generated waves that are within the coast. I will provide you an example of one such system that exists, which we have been developing. It covers this is Europe, north of Africa. So we have a system that has a area coverage of the North Atlantic, which then we use models like WAM or WaveWatch that are able to model the wave generation and propagation. And in fact, this coast of Europe is very much dominated by storms that are generated in Greenland and then propagate across the ocean to reach these coasts. So we need to model this whole area. And then we have a smaller area close to the coast with a coastal model which receives boundary conditions from these other ones. And then in an integrated way, we are able to combine both the propagated swell with the local wind generated to assess what are the wave energy in coastal areas. So this system, which can also be used for forecasting, which means forecasting will give predictions for the future, typically 5 to 10 days ahead. This forecasting system then starts from a global atmospheric model, and this is produced by the meteorological offices that make this available online. And then we can use this global distribution of wind to force a wave generation model across the ocean, and also to force an atmospheric model, which I will talk a bit later. So then the ocean wave model will give boundary conditions to the coastal wave model, which will then forced by a atmospheric model which produces more fine grid wind than the global one. In the past, we have used MM5 model. Now we use a WRF or WRF model, which then also produces high resolution winds close to the coast, which then will force our high resolution wave model within the coast. And this has then very fine grids very close to the coast. Here we are showing the entrance of major ports in Portugal, but this also covers the wave energy areas. We have one pilot zone around this area in the center of Portugal for wave energy demonstrations, so we can have detailed information of wave conditions very close to the coast. Now, as I said earlier, the problem with the wave power is that it is still expensive. Wave power companies need more research and development to develop concepts that produce lower energy, and we will be showing the different type of concepts that have been used. The concepts, the wave energy converters then interact with the waves to produce motion, and the relative motion between two bodies then will be transformed into electricity. That's the main idea. We have bodies that are typically called the displacers, that are bodies that are moved by the waves, and it can be the moving body can be either a floating device, or it can be a mass of water that goes up and down with the wave, and then it is the floater that is stationary. Or we have reactors that are bodies that provide a reaction to the displacers. So these bodies tend to be relatively fixed. Either it is the sea bottom, or it is a second body that has very slow motions, while the displacer has a large motion. So it is the difference in the motions of the displacer and the reactor that gives the motions that are being transformed into electricity. Now we have wave energy converters. There are many concepts of this type of converters, and even after many years of development, we still see new ideas of new converters coming up with different geometries. But basically, the main working principle is either to have a relatively stable platform and to have a water column that is oscillating, or to have two bodies oscillating relative to each other. And we have still a third possibility, which is to have an overtopping device. which is a device on which the waves come over the top and then fall within a reservoir, and it is the difference in height then between this reservoir and the free surface that then is used for driving turbines. These oscillating bodies can be the point absorber or attenuator or terminator, and I will explain immediately what are the differences between these different ones. And we can have these devices on shore, installed in breakwaters, for example. We can have near shore, so in very shallow waters, or we can have them offshore at a more a larger water depth. So the let's see then the oscillating water column. This is the principle of you see here a water column installed in a breakwater on shore. Then it is open. It is open to sea. It is open to sea in this region. So when the waves come, then we have the water level inside is going up and down. And when it goes up, it compresses the air, which then flows out. And when it comes down, then the air flows in. And then you can see that having a turbine here, especially one that operates in both directions, then this produces the motion of the turbine. And you see here examples of devices. This is in a breakwater, and this is a floating device that operates in a similar principle. You have here the caisson where the air is compressed. Now, the overtopping device is a larger device. We have here the example of the Wave Dragon that was developed in Denmark. The structure is here. And basically the waves, when they come, they overtop and they fall within this reservoir. So if we see it sideways, we see that the wave is coming, it goes over the top, goes here, and then it goes to this reservoir. And then it is the difference in heading between here and the outside that then is used to produce energy. Now, to converge the energy of the waves, these are used so that the energy of the waves incoming on this area then is concentrated to increase the energy that leads to overtop. And we see here a photo of one such device with the waves incoming in a prototype test in Denmark. Now we see the oscillatory bodies, which are the ones that probably have the largest variety of concepts. We have buoys that are floating, and then the motion is used for producing the electricity. We have concepts in which we have a floating body and a larger body inside the water, and then the motion of this submerged body is very small, and then the relative motion along this vertical axis then is used to transform the energy. The point absorbers are very small devices as compared to the waves. So the waves are not disturbed by these devices. And because of their size, the amount of energy that they are able to capture is relatively small. So they need to be operated in arrays of many devices And there are concepts of floating platforms with many devices connected to try to take advantage of these to have a concentration of devices. This is still in development stage, I must say. We have the terminator type of devices, are the ones that are perpendicular to the direction of propagation of waves. This is a concept developed in Denmark, where we have these different elements perpendicular to the wave direction. And in fact, this is a combined platform because it also has small wind turbines in it. Here we have the Salter duct, which is one of the first devices to be invented. As the waves come, this outside body that has this non-symmetric shape then will rotate back and forth. And the relative motion between the rotation of this outside body with this inside one is what is then used for producing energy. And this body is in a line. This is a cylinder that is perpendicular to the wave direction. Now the attenuators, as they are called, they are along the wave propagation direction. This is a Pelamis. It's a device that has been tested in prototype both in Portugal and in Scotland. The idea is that when the wave propagates along the device, the different sections will go up and down, and the rotation motion at these intersections will be used to transform electricity. We have other type of devices where they have sort of a central body that works as a reactor, and then it has articulated arms that float up and down, and then the rotation here is used for producing energy. We have a case here with 3 elements. We have one here that is coupled to wind turbine to take advantage of existing devices at sea. So these are the so-called attenuator devices, and this is the principle of their operation. So I would say that then we have different power takeoff systems, which are then the ones that will be transforming the relative motion into electric power. They have different operating principles. Some are the air turbine or water turbine, and that these are used in these oscillating water columns. We have also hydraulic systems. We have direct drive, which have been used, for example, in these buoys that are fixed to the bottom. The hydraulic systems can have different type of working fluid. Oil can be used when we want to have high pressure. If we can operate with low pressure, then water can be used. We can have these power takeoff systems in different positions. It can be in the machine itself. It can be on shore. It can be on the surface. But in general, these power takeoff systems are made with as much as possible of the shell components, and then they will need to have control strategies implemented to be able to take advantage of the efficiency. So there is no one of these systems that is a good one. The different solutions are good for different conditions. So we see different PTO systems offered for the different concepts. Now, when we want to have an idea of the energy produced by a device, we need to be aware of the different stages that need to be considered in this process. So when we are evaluating the wave energy resource, which is how I started this description, then we have the wave power. But not all the wave power then is captured. We call the intercepted power the one that the device is able to intercept. So if we have a very small buoy, then the area of contact between the device and the wave is very small. So the intercepted power has to be small. To increase this, we need to have a very large device that will increase this interface. So this is the first step of filtering. So depending on the size of the device, so the intercepted power will depend on that. Then we have the captured power. The captured power depends on the ability of our power takeoff system. So our system to transform motion into power, then we'll have a given efficiency, and therefore only part of this intercepted power will be captured. And after transforming this into electric energy, this has to be transported to shore, and it has to be delivered to the net, to the grid, electric grid. So this is the delivered power. And you see that at each stage, we have a efficiency that is being reduced. So this delivered power can be 10 to 15% of the initial wave power. And we want to improve the efficiency of these stages to make the process more economic. Now, the outlook for the marine energy, there are different international bodies making predictions. The predictions are that there will be an important growth of the sector by 2040 as compared to 2020. And these are the predicted growth if the current policies are being used. Now, if new policies and even higher policies are being taken, especially in the context of climate change, we can have a larger growth of this energy as predicted. Now, if we move into wind energy, this gives you an overview of where we have high wind energy. You see many locations onshore, possibly related to high mountains. But you also see, if you look at the coastal areas, you see these red areas where you have high wind energies in the coast. And this shows the areas where wind energy can be well explored offshore. This shows an example of the assessment of wind energy close to Portugal. This is the wind speed at 80 meters, which is the 80 meters height, which is the reference condition for the turbines. And this is the distribution of power that is expected. And we see here the seasonal variation of the energy from winter to spring. And this is produced by numerical atmospheric models. So those are the technology that are available to indicate the power and its distribution in space. Now, if we move to the turbines, let's see what are the elements of the turbine. The horizontal axis turbine has become the standard. There are also vertical axes and there are other models, but what has been commercialized is really the horizontal axis. Here is an example. Nordex is a typical turbine from onshore, but the elements offshore are similar. We have the blades, typically 3, the hub where the blades then are fixed. We have the main bearing that connects the blades to the rest of the structure, which is then the gearbox to transform the speed of rotation of the shaft. And then we have a generator. And those are typical elements in all types of turbines. Although we are having a new technology, the so-called direct drive, in which they avoid the gearbox. But most turbines nowadays have these main elements, and there are different types of designs. The more modern designs have more control and electronics, but those are the main elements, and normally they are being monitored for condition monitoring.
Excuse me, Professor Suarez.
I have the impression I am going a bit over time. Is that the situation? How much time do I still have? Maybe Professor Alkan can give me some idea of the time available so that I can manage the end of the presentation. Well, I cannot hear, I'll try to go a bit further. So in offshore, we have the same elements, but we have the marine environment, which creates the difficulties of corrosion and higher levels of degradation that we have to deal with. This shows the process of installing the typical wind turbines. This is an onshore installation. In offshore, this component is the same, but of course the foundations are different. So offshore, the fixed bottom turbines look like this. So we have again the shaft, the transition, and then we have also floating platforms. These are the typical foundations of the turbines. This is the monopile, where we have just one element in the sea bottom. This is the sea bottom. We have gravity-based structures where it is the weight of this base that keeps the structure in place. And then we have other concepts that have more than one pile. This has 3. We have a jacket where we need a stronger support. And then we have another one with three piles. Now, the monopile is used for shallow waters up to 30 meters. When we move to 25 to 50 meters, we need a jacket. And then if we want between 50 and 120, we need floating structures. This is a tension-like platform. It's a platform with positive buoyancy.
Excuse me, Professor Suarez.
Excuse me, Professor Suarez. Yes. I was
sorry to interrupt you. Can you please conclude
All right,
complete your presentation in 5 minutes. There
Yes,
will be,
yes, okay.
another 3/4 of hour for Professor Atlar. In 5 minutes, please. Thank you.
Very
Very
well.
interesting things, but time flow. Thank you.
All right. This gives you the idea of the distribution of the structures worldwide. 76% are these monopiles that I indicated, 12% gravity, and the other ones are really small. You see that this is the distribution in Europe. In Asia, monopiles are relatively small because they have soft soils and they need to use a different type of foundations. But overall, these two together are similar to the distribution we have in Europe. Now, the floating energy, the wind parks, the blue ones are the existing ones. This shows the water depth that goes up to 30 to 40 meters, and this gives the distance to shore. So typically, this is 40 kilometers from shore, and it can go up to 140 meters water depth. This gives you an idea of the status of development of floating wind energy. So to conclude, I would say that the wind energy is expected to develop further with commercial parks in the future. Wave and tidal energy are at the border between demonstration and commercial exploitation, and its development will depend on public policies to give incentives to commercial exploitation. And overall, the sector of renewable energy offshore is really important to be considered in the so-called blue economy that looks at the wider use of maritime spatial planning. So thank you for your attention. I'm sorry to have gone a bit too long.
Thank you very much, Professor Soares. Do you hear me now? I test again.
Yes.
Thank you very much. You could show us only a few slides. I think the subject is more complicated, more efforts, more studies, huge studies you have done with your team. Those were very interesting. Still, there are questions to have your presentation file from this hall here, colleagues. All are very interesting. I thank you on behalf of the Congress organizers, with all colleagues. I thank you. Before completing your meeting now, we would like to physically give you a plaque for the memory of this Congress. I would like to give this plaque. It was written your name and also the date, so on information. Acaba görebiliyor musunuz? Efendim? This is your plaque. This is your plaque, Professor Soares.
Thank you very much. Thank you.
Excuse me. Here is.
Thank you.
Thank you very much. Thank you, Professor Mehmet Atlar. Welcome to the Congress.
Thank you, Ahmet. Thank you very much. Can you hear me properly?
Biz sizi duyabiliyoruz diye de söyleyebilirim. Yes, we hear you very well.
Excellent. I am also hearing you very well.
Thank you very much. Professor, I would like to introduce Professor Mehmet Atlar. He's working, his university is University of Strathclyde, Naval Architecture and Marine Engineering. He had degrees in Istanbul Technical University, then he worked at the Newcastle University, is dealing with intensively work on experimental hydrodynamics, experimental ship research, and also computational naval hydrodynamics. Of course, he had many PhD students, researchers, provided very intensive collaborations with our colleagues. Also, they are here. I would like to introduce his speech now. Professor Mehmet Atlar will talk on a bold retrofit challenge for greenhouse gas emission for Turkish maritime industry. It is a 2020 Horizon 2020 project, Gators project. They developed, may I say, invented a new type of rudder, a large innovation they improved, they made with ship propulsion plus ship maneuvering. The floor is yours, dear Professor Mehmet Atlar.
Thank you very much, Ahmet. Thank you for your warm welcome, and let me just share my screen, please. I hope you can see me all, and you can see my presentation. If you can confirm, please, if you can see it.
Please go on. Thank you. Confirm.
Okay, that's great. So in that case, let me just move on to my presentation. As Professor Alkan stated, I call this presentation a really bold challenge. That's as a retrofit and to reduce the greenhouse gas emission. And I also said that that's for Turkish maritime industry. I think this is interesting for this conference, and then I would like to explain you why this is a good challenge for Turkish maritime industry. Let me tell you, although I am presenting this paper, there is a lot of people behind, at least 18 partners, European partners of my project. But as a group in Strathclyde University, I have Batuhan Aktaş, Dr. Batuhan Aktaş, and Mr. Ahmet Gürkan, and also long-term friend, and also the inventor, actually, one of the inventors of Gator, the Professor Noriyuki Sasaki, who is also member, visiting professor in Strathclyde University. So we are all from Department of Naval Architecture, Ocean and Marine Engineering in Glasgow, United Kingdom, and it really is my pleasure to make this presentation for you. And obviously our challenge by using this so-called gate rudder, it's a novel energy saving system, and that's what it is all about. So first of all, what is actually a gate rudder system? Let me explain to you. It's got almost now maybe 6 to 7 years history. So you think that the classical rudder behind the propeller, whether it's a high lift rudder or just a sort of conventional rudder, is swapped, or the change, you can see that with having two rudders, smaller rudders, along the propeller, aside the propeller, you can see that one is in here, another one is in here, and then each of them can be individually moved. The other interesting thing, of course, like the conventional rudder, this rudder also has got a profile section. Therefore, it acts like a duct, like a nozzle around the propeller, and hence generate thrust, additional thrust, as opposed to a conventional rudder always actually generates a drag or the resistance. So getting rid of the resistance and adding to the thrust of the propeller, that means, you know, we are improving the propulsion system. As well as that, having two rudder that can be individually controlled, so we are also improving the so-called the maneuverability and even course-keeping ability of the vessel. So that is the all gate rudder is about. Why it's gate? Because our colleagues in Japan who actually invented it just looked like a gate. So that's what they call it, gate rudder. So, okay, let me move on to, if we have the gate rudder, then what happens? First of all, you may end up with a remarkable fuel saving. Officially in trials, that's 14% plus. More than that, when the vessel hit the service condition, i.e. when it's operating in rough weather, this can be as high as 30%. It looks like unbelievable numbers, but it is the truth. That can be as high as 30%. Then why? Because that improves the vessel's motion, especially in the lateral plane, in yawing, and also vertical plane in the rolling motions. So then, obviously, as I mentioned, it improves the steerability, controllability, and the maneuvering. And, you know, especially in harbors, you can see like in this, vessel can go sideways like crab. And in harbors, that's a very, very handy maneuverability, and so on. And the very rate is actually the discovery. When I say discovery, I mean the full-scale trial indicated that, demonstrated, we know that from the computations, that you will have less vibration and also a tremendous reduction on the propeller-induced underwater radiated noise. We're talking about maybe 15 to 17 decibel reduction. So that's a hot potato at the moment, is being enforced by the IMO. Then there is actually a reduction in the hull wake at the behind the vessel at the stern. Then of course that when you think that you are getting rid of the conventional rudder and bringing forward, that means you may have a shorter vessel or more load carrying capability. In addition to that, you may also have effective bow thruster used at higher speed and maybe reducing the risk of running anchor. So you don't need to have a long chain of anchor. You can do it with a shorter one. These are all experiences we got from the existing captains of the using these vessels with gate rudders. So how? I will give you more detail. So let me move on. First of all, a brief history. How did the concept was developed? The gentleman you can see here, Mr. Kurobayashi, who is now almost 100 years old, and he actually was the first one and comes up with this, you can see that a concept, which is called, he called him a frame rudder. His idea was, especially for the coastal vessel, to use the propeller slit frame and then like a water jet and then change the direction of it and then improve the vessel's maneuverability. That was in 2011 and 12. You can see that. He applied one of his ships because he's also a ship owner. They own actually almost 50 ships in Japan under the Kurobayashi Steam Co. So then he couldn't get the efficiency that he was looking for. Then eventually he went to NMRI, National Maritime Research Institute of Japan. There, my long-term colleague, almost 30 years we know each other, with Noriyuki, Dr. Noriyuki Sasaki, and he was one of the senior director, and also I must say he's another genius friend. He's got so many propulsion devices, and he asked his help, saying that, look, you know, can you help us to improve this? And colleagues in Japan, Noriyuki, and also colleagues in NMRI, they looked at it and then they said that, okay, let's move this rudder alongside the propeller. And also it's better to sort of operate from one rudder stock at the top. Then suddenly they noticed that 5% or so improvement, because suddenly this rudder is looking like a duct and then introducing thrust, whereas here, like a flat plate doing nothing, just to improve the steerability. But suddenly, when you bring along the side and with the foil, then you start to operate like a duck. So this was very good. In fact, they got a patent for it. You can see that there's a Japanese patent. It's some of you may say that, oh, this is looking like a saddle duck. You know, there is also a terminology like a saddle duck. You put onto horses and donkeys and etc. like a saddle. So anyway, after that, that was in 2013-14, and Noriyuki, Dr. Sasaki, has come to Newcastle, where I was working there, although I moved to Strathclyde University now. Then we start to continue further work on this one, and then the concept came up with separating this rudder and then individually controlling it with two steering gears and etc. So a lot of research has gone into in Japan as well as in Newcastle and Strathclyde, and eventually second patent actually from the colleagues in Japan is claimed. That was, as well as the Japanese, it was a European patent. So you can see that the concept from this and then has become that. Now also a Japanese Nippon Foundation sponsored a demonstration project in 2015, 16, 13, for 3 years, and then to demonstrate the concept. Then this concept was actually put on to a vessel called Shigenabu. Shigenabu in Japanese actually is a Japanese warrior. So then the concept was in the water in 2017. That was the first gate rudder system application in Japan, and that was a container vessel, a feeder, as you can see here. It's almost 110 meters with a propeller of 3.5 meters, that's the diameter of 3.5 meters. And then, so it has gone into water in 2017, but before then, a sister ship called Sakura. Sakura in Japanese means a geisha, a Japanese traditional as you know, the lady geisha, and that was the name of Sakura. And she has gone into water before Shigenabu, almost 1 year. But the most interesting thing, these two vessels were exactly the same engine, same draft, everything is the same. The only difference was one has got gate rudder, another one has got single flap rudder. So, and as I mentioned, Shigenabu came 1 year later than the Sakura. Of course, that both of them were put into official sea trials, and then the results indicated remarkably favorable performance for Shigenabu that I will show you in the later slides. Okay, then what is the gate rudder situation at the moment on a commercial sense? Are there more ships? Yes, there are more ships, colleagues. After Shigenabu, there was 2 vessels, Koshin Maru, that was in the water in 2020, and also Shinmon Maru. You can see that these vessels are also small coastal vessels. Why they are applied on small vessels? Because it gives more maneuverability. Can they not apply to large vessels? Of course, but at the moment, there are actually further development commercially, which I will include, but at the moment, it's all cargo vessels. By the way, none of them are retrofit. They are all new ships. Then, since then, these 2 vessels are in the water, and also they are producing a remarkable gain as before Shigenabu. Then at the moment, there is 1 larger container vessel. That's the maximum size for a coastal ship in Japan is being built. She'll be in the water 2020. And also a new training vessel, which will be built by Mitsubishi for the next year. So 2 more vessels will be in the water, plus 2 fishing vessels in order, and also 1 medium-sized LNG is being investigated, and 20K, a much larger bulk carrier, are also being investigated. They may be become an order soon. These are very latest information. So that is the sort of application for this vessel. Now, what about the commercial status? As I mentioned to you, there are 5 members of industry consortium involving the obviously major patent holder, Kurubayashi Steamco, and my colleague, Dr. Sasaki, and also NMRI, National Maritime Research Institute, Yamanaka Shipyard, and Kamome Propellers. These guys actually, first time with the Nippon Foundation, applied the patent and got the patent, so there is actually a patent. Now, later on in Newcastle and Strathclyde, we actually contributed into this and then developed the system further. Then in 2020, as you know, the major stakeholder, Wärtsilä Propulsion, decided to purchase actually the patent user right from the Japanese consortium. So that means Wärtsilä actually owns the applications of the gate ladder worldwide. But before then, in fact, I was the person that I established this link with Wärtsilä, and then they actually eventually purchased the concept. But before then, we have actually applied for Horizon 2020 project called Gators. What we were thinking in this project, can we apply gate ladder as a retrofit rather than as a new vessel, so that and then the concept can be applied almost every vessel. So that proposal has been obviously accepted by Horizon, which I'm going to explain to you. But in the meantime, having the Wärtsilä sort of purchasing this concept, we had to do sub-license agreement with Wärtsilä. But I must say that the Gator has got the full right commercially to exploit the concept, applying for the coastal vessel. There is no problem. In fact, we are collaborating with Wärtsilä in many ways. Okay, coming back to the advantages. As I mentioned to you, now let me go into a little bit more detail. Colleagues, you can see that here is the power curve, and then here is the ship speed, and then the red curve here, official trials conducted in 2016-17 by Shigenabu, and then the green line conducted in 2016 at the same trial area for Sakura. You can clearly see the 14% saving in power as far as the Shigenabu is concerned. On the other hand, when these vessels moved on to service condition between, you can see this diagram, that 2018 until the 2018, for 1 year, collection of the fuel consumption data. The red one belongs to the Shigenabu, and then the blue one belongs to the Sakura. You can clearly see almost 30%, even sometime over, especially in the rough seas, far more actually saving for the power for the Sakura. So these are clear advantages. And also these two vessels are still under further trials. As you can see here, last year, a joint sea trial was conducted in Japan. You can see that that is Sakura, and also that is Shigenabu. There is only 300 meters B-bond, one following the others. And then at the same RPM for 3 different, if you like, the engine loading condition, these vessels' power was measured and speed was measured. And then you can see that this saving actually, again, confirming 14%, even more than that, 18%, you can see that the speed difference between the Sakura and then the Shigenabu. So after almost 3 to 4 years, these vessels still performed as required, as found actually in the first trial condition, providing almost 14 to 15% and power saving. I must say, this is incredible for an individual energy saving device if you are improving the fuel consumption. Now, as I mentioned to you, apart from the power saving, the other superiority is the maneuvering. You can see that having the gate ladder and individually operating, you can have different modes. In the navigation, 3 to 5 degrees, by moving the rudders, you can save power. again, in the navigation, if it is in the rough seas and then a little movement, also you can harmonize the loading coming on the engine. That will also help. And then in the steering mode, you can steer the vessel minus to plus 10 degrees and then to conduct various, if you like, the maneuverability in harbor. And you can do the circle mode by moving the rudder blade as shown in here. And you can conduct crash stop actually like water jet and changing the position of the steering bucket. You can think of that these rudders actually working like a steering bucket. And finally, as you can see here, by moving the rudder blades plus 110, another 60 degree, you can do a crabbing motion, going the vessel sideways, which is very, very valuable maneuverability when you are docking and then when you are moving away from a quay, which you can only do by using, in certain cases, thrusters. In obviously gate rudder case, you will not need stern thruster, maybe the bow thruster only. You can see that the stern actually from the gate rudder and then the bow from the bow thruster. You can see that how the vessel is conducting crabbing. And moving on, further details on the maneuverability. As I mentioned to you, you're getting rid of the rudder drag. You can see that a high lift rudder is going to generate a drag actually as percent of the thrust. You can see it in here, whereas a gate rudder will not. That there will be no drag. In fact, there will be a thrust adding to your further thrusting the vessel. You can also see here the comparison of the resistance and then again due to high lift rudder and almost less than 50% and the resistance for the gate rudder. You can see when you put the helm angle at 20 degree, 40 and 60 degree, the difference between the two. The impact of having the gate rudder will have a obviously effect on the turning circle. You may say that with a flap rudder, you may have a smaller so-called turning diameter, tactical diameter, whereas with the gate rudder, your tactical diameter will be larger. That is okay, but the speed when you're conducting a circle maneuver will be much higher compared to the speed when you're doing with the flap rudder. Then of course at zero speed, the tactical diameter will be smaller. Now, if I may show you this a bit more clearer diagram, you can see that the gate rudder has got the much larger speed, turning speed compared to the conventional rudder. You may argue saying that, oh, I would like to have smaller circle diameter. And then because then, you know, avoiding the accidents and etc. is much better, but you also need to think about it so much, if you like, the loading on it, and then suddenly you're having a very shorter circle tactical diameter, then you will run into other trouble. And also you would like to have vessel speed in your control that you can do a better maneuver. So there are pros and cons of this. But one thing is very clear, during the zigzag maneuver, you can see that overshoot angle 10-10 and then 20-20 for the gate rudder is much smaller compared to the normal conventional rudder. This shows you that your course keeping ability much better compared to conventional rudder. I mentioned to you that the vessel's motion capability, yawing, and then the rolling is much better. Here is actually a trials again, last year's trial, Sakura at the back, conventional, and also Shiganobu at the forward. The distance between is at 300 meters, as I mentioned before. And then these are the records of the yawing of Sakura, conventional vessel. These are the records of yawing from Shiganobu by using the gate rudder, of course, in the control of small oscillation. You can see the difference between the two systems, how yawing of Shiganobu much smoother compared to the Sakura. And then ship speed in both cases are exactly the same. You know, this is round about 15 knots. On the other hand, rolling motion recorded on board by using inclinometer, you can see here that Sakura indicated 3 to 5 degree rolls, whereas the Shigenabu actually that was reduced to 1 to 3 degrees. So the rolling motion also are being reduced. So these are the advantages also impacting on the fuel consumption, like on your added wave resistance and etc. Okay, so these are actually the current advantages. I did not actually show any, if you like, diagram to you on the vibration. I can assure you that there is actually a very recent trials conducted in Japan, and then it indicated that gate rudder actually reduced the propeller-induced underwater radiated noise between the 1 kilohertz to 10 kilohertz, almost up to 15 decibel, 15 to 17 decibel. This is excellent, actually, for noise mitigation purposes. Taking all this into account and then conducting this research almost 4 years, and between 2014 to 2018, and we decided to ask European Commission if they can actually give us some funding to conduct further research that actually should dedicate it to retrofit. So now I'll move on to Gate Rudder, Gators project. That actually stands for Gate Rudder System as a retrofit for the next generation propulsion and steering of the ship. So what was the motivation? Motivation is obvious, colleagues. You can see that what we can achieve with newly built vessel. Can we do this retrofitting? Just take a box standard vessel, strip off its rudder and then the propeller, and then put there as a retrofit gate rudder. And can we achieve something, maybe 10%, over 10%? I think that will be advantage. So we know that there wasn't any application and so on. So there was actually a call in the meantime from European Commission, and then we applied for it. By the way, these were our inspiration when we applied, but very recently, as you know, all the existing vessel, Ahmed was mentioning in the morning, IMO's recent greenhouse gas emission requirement indicated that by 2023, all the vessel has to satisfy EEXI. So that means you got to do something on your vessel. That's what I am saying, or we are saying, that gate rudder is your savior, is your best bet compared to the other system that you should consider. Now, okay, then what is the aim of the project? Very clear. First of all, bring 18 technology expert colleagues from shipyards, classification society, universities, ship owners, design offices, everybody. We got European technology expert. And then we wanted to develop a methodology, i.e. use the computation, model test, and full scale, come up with a methodology, how you can do retrofitting effectively. That is our aim. And demonstrate this on a ship. That is also our aim. We have to demonstrate technology readiness level should be 9. You know, that must go into the water. And also at the concept level, we also have to demonstrate how this can be applied to larger vessels, larger containers or bulkers and etc. as a desk study. This is not an application, but the desk study. So we have to demonstrate the impact. So what's happening on the greenhouse gas emission? What's happening on the cost? What is the cost of this? So this is all the aim of Gators. Okay, then, if this is the objectives, basically develop the methodology, demonstrate on a vessel, and also show the impact, how you're going to achieve this objective. And then we said that, first of all, we have to use all the methods, experiments, full scale, and then the a computational method, and then develop these procedures. And then after that, as I mentioned, detailed design of the concept, like the rudder, propeller, shaft, aft end modification, and everything, detailed design, and also manufacture this, and also apply on a vessel and monitor it before with the conventional vessel, after retrofitting with the gate rudder over the 3 years period, clearly state what is the catch, what is the advantages of the system. So then what is the impact on EEXIs, and what is the impact on the life cycle cost? So these are all the objectives. And of course, that also demonstrate at a fleet level. If you have a coastal fleet, if you have large ocean-going vessel fleet, what will be the impact? So that's also our objective in this project. Okay, what are the phases of the project? We are in the phase 1, by the way. Started last February. Until next February, we are going to develop all this procedure. And then in the phase 2, next year, then we are going to manufacture and then install on the vessel. Installation, by the way, will be sometime in September. Then I hope that we invite all the colleagues in Turkey, because installation will be in Turkey and also trial will be in the Marmara Sea. So then you can all see it. That's in the September 22. And then after that, we will be continuously collecting in-service data. Then we will be analyzing the vessel's performance. Okay, who are the partners? We have 18 partners. Obviously, as a coordinator, University of Strathclyde is the coordinator. I am very proud to be actually the coordinating or the manager of this project, and that to make this presentation to you and take a lot of pride out of it. We have obviously HCBA or HSVA, and then as the major testing facility, we have Bureau Veritas, because our target vessel is a BV classified vessel. So BV is working with us. We have our design office from Greece, Glafkos Marine, that's the design office. And we have CNR, Italian Navy research testing facility. And then they will be conducting model tests for us. And from Turkey, we have Hydrotechnic, SME colleagues, and Professor Mustafa İnsel's company. They are working as the consultant in the project, like one of the design offices. Of course, that my alumni, where I was graduated, Istanbul Technical University, heavily involved by conducting model tests. And then from UK, TWI is another structural design company. And then from Malta, Naval Architectural Services, NAS. And now Çapa Denizcilik from Turkey, they have very important role, because they actually let us to have apply our concept gate ladder on their target vessel. They have a general cargo vessel, which I'm going to explain to you. ERGE, we are going to apply our gate ladder ERGE on their vessel. So they are very important partner. We have Sintef Ocean from Norway, another design office. We have very large company, ship owner company from Cyprus, Danos. And we have one of the major propeller designer and the manufacturer from UK, Stone Marine Propulsion. And very important, we have Gürdesan from actually Turkey, eventually will be manufacturing, installing the gate ladder and then the shaft and the propeller and putting on the ERGE. So that is Gürdesan. And we have my ex-university, Newcastle University. We have very large ship owning container company, that's Starbulk from Cyprus and Greece. Then we have Lloyd Intelligence, so-called the database company from United Kingdom, and eventually we have Fincantieri Design Office Cetena, who are actually doing all the service performance monitoring. And as you can see, colleagues, there are 18 partners and 4 of them are from Turkey. This is why GATES project is very, very important for the Turkish maritime industry. Then if you look at the partners' background, you can see that the major partners are from UK and also from Turkey. Turkey actually 22% contribution in the project in the consortium. The remaining partners, obviously from Norway, Malta, Cyprus, Sweden, Germany, France, Greece, and then Italy. So it is a very large consortium from many countries. In terms of the type of the partners, you can see that 28% of our partners directly from industry, and 33% also from industry and also consultancy, small and medium enterprises, and then the research like the universities and also design research is about 30%. There is very nice balance, almost 30%, 33% from different experiences. How we're going to achieve these objective and aim? In the project, colleagues, there are 6 work packages. In the first work package, which Strathclyde is coordinating, we will be developing the methodologies, how to do the retrofitting. In the second work package, actually, Cetena Fincantieri's research office will be conducting full-scale trials together with Hydrotechnic and also voyage monitoring. They will be continuously monitoring the vessel by putting their thrust meter, torque meter, speed and wind and waves and everything. So we will be continuously monitoring the vessel's performance. In the work package 3, that Hydrotechnic will be organizing detailed design of the gate rudder for Erge. The target ship will be conducted. In work package 4, Gürdesan is taking over this. They will be manufacturing the gate rudder component, i.e. shaft and rudder, and then the propeller, and as well as the steering gear, selection of the autopilot, and everything after modification. Then in work package 5, we will be doing impact assessment. Okay, then we have gate rudder applied on Erge, and we have gate rudder applied on other ships and then the fleet. What is actually the impact on the regulation? What is impact on the fuel consumption? What is impact on EEDI? What is impact on EEXI? So that will be done work package 5. And work package 6 is all economical cost evaluation. That will be done by colleague like Synthet. Obviously, there are other work packages. 7, communication, dissemination, exploitation. Colleagues, I am here. I am doing dissemination at the moment. This is what we have to do. We have to communicate, and also we have to exploit. We have actually demonstrate, we have to sell the concept to potential customers and so on. That's all being done in work package 7. And then TWI is looking after this. Work package 8 is the project administration and the management that I am actually working on it, and together with my colleague in Strathclyde. And finally, we have the final work package ethics requirement as required. We have to make sure that whatever we are doing in outside European countries, like in Turkey, everything should be ethical, everything should be according to the rules and etc. Okay, let me a little bit talk about our target vessel. That was Erge. You can see Erge's details. There is a picture of it in here. And then this vessel actually is about 90-meter vessel, and then 5,650 deadweight ton. And then it was built in China and later on bought by Chapa. And then, in fact, it was built for carrying wind turbine blades and etc. A very unusual ship. It's got a very large block coefficient. We're talking about block coefficient of 0.83. So it's very tricky. When we were doing the model testing and etc., we noticed that we have to be very, very careful about it. Now, the vessel operates in the, of course, coastal water, but it also goes to places like Red Sea, North African waters, and etc. So that belongs to the Çapa Denizcilik, and then we are grateful to Çapa letting us to utilize their vessel. Then hopefully we will demonstrate the entire Turkish maritime industry and the world, really, and Europe, how the concept can be efficient. And also Çapa has got exactly a sister ship. You can see that Erle, it will be very interesting to compare Erle and Erge, what will be the sort of catch up over the year. That will be done, of course, through the project. Okay, I will not bore you, but you can see that how this work packages from work package 1 to 9 is being organized. Every single task here is under control, and then this is in the work package, how we develop the procedure, and this is in the second package where how we're going to do monitoring, and then work package 3, how we're going to conduct the detailed design and what time and etc. These are all actually provided, as you can see it in here. Then let me just move on to this one and all these work packages. Okay, how we're going to manage the project. Colleagues, we have actually General Assembly every 6 months. We come together and then we make an overall review of it. Of course, we have a steering committee and then involving all the work package leaders. Then we come up every 2 weeks and every month and then discuss our so-called progress. This is very important. We have industry advisory board. In this industry advisory board, we have very important users, which I'm going to show in the next slide. And I would like actually here one of the very important Turkish customer to be member. That will be hopefully COSTER, Turkish Coastal Vessel Operators Associations. Hopefully we are in touch with them. They will be our members so that we can demonstrate if this can be taken, this advantage can be taken by the COSTER Association in Turkey. Then obviously the project manager at Strathclyde University and myself, we are actually doing this. Apart from this sort of managing part, we also have advisory, so-called communication dissemination board. We also intellectual property board. Then of course that we have the work packet leaders. Then we all operational bodies that we sort of manage this project. I mentioned to you that we have an industry advisory board that actually we report them every 6 months. What we are doing, can you give us some idea how we can exploit the concept? Who are these members? We have Royal Caribbean Cruise Limited, and then Dr. Thor Svensson from there is one of the members. And the other one, of course, Wärtsilä. Wärtsilä is the main, if you like, the patent holder, not the patent holder, but they bought actually the commercial right of the concept they hold. So they are our member of the advisory board. We have Hellenic Tanker from Greece. They have almost 100 tanker vessels. They are heavily interested in if they apply the concept on their bulkers and tanker. We have investment company, Oscar Propulsion from UK, and then they are looking at if they can make a further investment on the concept. Then of course from Japan, Kurebayashi Steamco, he is one of the patent holders, is our member. And Shell, actually, Shell also a member. They are seriously looking at to apply the concept on their, especially LNG vessels. So they are also a member. And finally, and I am very pleased to see also Mr. Zeki Salih Çakır. We have been in contact when he was the head of COSTER, and later on now we are talking with Ms. Pınar Kalkavan. If the COSTER will be a member, then I am sure they will be a member, and then we will be very, very pleased actually to have them on board and then give them demonstration for every 6 months on our progress. What is the financial, if you like, the situation? This project has got, colleagues, almost 6 million euro, and 5 million euro of this budget is coming directly from European Commission. Another million, I would say 900,000, is coming from our partners, because industry partners can only qualify 75%. So 25% is coming from the colleagues. So what about the duration? It's 3 years. And then 3 years, at the moment, we almost into month 8. As I mentioned to you, and when the next year summer comes, hopefully our vessel Erle will be having retrofitted. What is the project's progress so far? As I mentioned, we kicked off in the 24th of February. And then since then, we have project website, and we are all on the social media pages. You can see that the website, official website, and European website, and then commission website, Twitter, LinkedIn, and YouTube, and everything is in here, so that you can have access what is going on. Now, what about the technical progress? we have active packages, work package 1, procedure development, work package 2, target vessel design, and also performance monitoring. Work package 3, detailed design and manufacturing is on action, and eventually communication, work package 7 and work package 8. The other work packages, 5, 6, they will be coming into action next year. So they are sleeping work packages, but at the moment, these work packages are in action. Let me go a little bit more detailed. Work package 1, what we have done so far. Colleague, so far, we have actually developed the preliminary design of gate ladder system for ERGE by using computational method in Starklight, experimental testing in Istanbul Technical University, and also full-scale measurement on board of ERGE with the help of CHAPA. We have actually designed, you can see actually how the the preliminary design will be eventually. I'll go into the detail. Now we have a model in Istanbul Technical University. This is 3.6 meters, small model, but CNR in Italy also doing the test. They are just kicking off now in Italy with the 6-meter model. I can tell you there is also a 10-meter model in HCWA in Germany. So that means we are looking into this scale effect. What happens? 3 meter, 6 meter, 10 meter on experiment as well as in the full scale. That will be all sorted out because gate ladder is a very new concept. Extrapolation is very, very critical. Now the detailed design also at the same time has to be going. You can see that Gürdesan and us already actually come up with some preliminary detailed design. You can see that we have the structure. These are all being finite element analysis conducted and etc. These are all being done. By the way, we started to talk to Bureau Veritas because Bureau Veritas has to approve the concept. Then, by the way, again, although this is being manufactured for stainless steel, but also we are considering for the larger ship, can we construct this one from composite? So therefore, there is a very interesting futuristic application. Composite material also is being investigated. So if I may just move on to the next slide, you can see that the Airlays model is already underway in the Istanbul Technical University. This is for the loaded condition. She is a very heavily loaded. I can tell you that CHAPA loads this vessel more than necessary, but that by all means. And also there is also a trial, so-called ballast condition test. We are all doing it. You can see actually our CFD simulations here. Here you can see that the resistance characteristics of the vessel, and then the towing condition is in the black line here, and also self-propulsion condition in the red line here. You can see that when the vessel starts to self-propel, how actually rudder is giving an additional thrust, and then therefore resistance of the vessel is being reduced. You can see already the resistance, how it's being improved in the CFD. And then moving on to next, I told you that we will be looking into scale effect. When you do a prediction in 3.6 meter model, you can see the separation region FD of 10 with the conventional rudder. When you move on to 6 meter, separation as in this scale. When you move on to full scale, separation is getting reduced. This is very, very critical. And to find out, when you move on to, this is for the conventional ship. When you move on to gate ladder, this separation yet still very high in the smaller model, but as you move into 6 meter and then full scale, the scale effect are reduced. And also with a 6 meter model, we should be able to have a quite good extrapolation for the full scale. So these are very interesting to see. And of course that this scale effect, you can also see in the nominal weight characteristic. You can see that CFD prediction with the conventional rudder, 3 meter, 6 meter, full scale, and also with the gate rudder cases, 3 meter, 6 meter, and full scale. You can see how 6 meter and full scale has got quite a resemblance, whereas 3 meter model has slightly different. So that means we got to be very careful with the scale effect. That's what we are at the moment is exploring, and then we will bring that into our procedures. Okay, This is an interesting simulation. You can see we already developed the concept, and then we can actually tell you what is the thrust on the propeller, and as well as what is the thrust. Every blade, every individual blade, you can see that individual blade thrust characteristic. This is a critical information for a finite element model that should be actually passed to Bureau Veritas, and also we actually have to demonstrate this by model scale test. Okay, what is this at the moment prediction level with the CFD and also with and in our model testing? It is not so bad at the moment. You can see that in the loaded condition, and then that's the resistance prediction. And also, again, in the self-propulsion condition, our prediction, red from the computation fluid dynamics, and then the black from the experiment. So we have some differences, but also we have further to look at with the larger models and so on we've been working on. But this gives us enough confidence at the moment to move on in the project and then get the detailed design, etc., underway. By the way, we are not only looking at the non-cavitating condition, and also with the cavitating condition, you can see that our simulation is underway. This should also operate to conduct simulation, but at the moment somehow is not doing it. No, it's okay. You can see, colleagues, that how the propeller is developing the cavitation, and also how the pressure on the each gate rudder system is changing, and then we will be able to compare these predictions with the cavitation tunnel test, which will be conducted in the Istanbul Technical University's new tunnel, and then we can correlate our results as well. So, as I mentioned to you, these are all to do with ERGE, but we also have, with the collaboration with colleagues in Japan, we also have Shigenobu and Sakurai's model built in Germany. This is actually, this week, the picture came to me from HVA. This model is almost 10 meters. These models will be going into the water, and then in October, we will be getting all the model test results, then we will be comparing with CFD prediction. This is also an integral part of the project that we have to conduct. Now, moving on to work package 2, I told you that the ERGE at the moment is being installed with the with the torque measurements, velocity measurement, thrust measurements, and also wind and wave measurements. You can see that ERGE's navigation desk also is being so-called fitted with the monitoring system, and you can see that the interface by Cetena. And also shaft region, the torque meter has been installed. Now we will be collecting data starting from 1st of October until next summer with the conventional shift. So we have all the fuel consumption, and then the torque, and then the speed, and then even some motion characteristics until next summer. Then after that, gate rudder will be installed. We are going to conduct further measurement, and we're going to compare it. But in between, and colleagues in Hydrotechnic will be doing, and also with Bureau Veritas and also with Cetena, they will be doing ship trials, actually official trials in outside Yalova, and then at certain part in deep water, and etc. These are all being planned. Now, coming to the actual vessel, the detailed design, you can see that, colleagues, we already actually worked out the installation of the steering gears, and then capability of the steering gear, and then the gate rudder, and then the shafting, and then propeller, and then all the supporting system of the gate rudder, and etc. Now we are talking to Bureau Veritas and get their approval. Hopefully that will be okay by February, next February and March time. So everything is underway, and Gürdesan is doing excellent job, and as well as all the colleagues in Turkish and Şapa Denizcilik has been fantastic to helping us, and then everything is going according to plan. Okay, I am almost at the end of my presentation. Why this is important for the Turkish maritime industry? colleagues, there is no other individual energy saving device that will give you 14% saving. This is so important. You can combine this one with your hydrogen, with your LNG, with your Bosch-Cup fins and everything. That will be additional bonus for you. You can put your scrubbers and so on. So please bear in mind, this is very, very important. And then second thing is, as I mentioned to you, this is a complementary system. This is a hydrodynamic complementary system. You can combine with anything. And then, and most important thing, EEXI is on your door. 2023, you have to have. Gate Radar is there. It is in Turkey. You can see. Then that will be manufactured in Turkey, in Gürdesan, applied on a Turkish coaster, and then will be owned by them. Then we are in contact with Coster. Coster, if they can see, then we can actually apply this, all these Coster vessels and so on. And most important thing, as I mentioned to you, Gürdesan the manufacturer, Çapa the ship operator, Hydrotechnic the consultant, ITU is the university, and Coster is they are the actually major stakeholder of the Turkish so-called maritime industry. So this is why this is important. This was my final slide, and maybe I will close my talk with a tribute to a great friend and colleague, Mr. Mustafa Gürsoy of Gürdesan. As you know, we lost him. Mustafa Gürsoy was a great friend to me. You can see our friendship goes so many years. It's in the technical university, contributed in our research vessel. When I was in Newcastle, he came and helped me to sort out the problem with our cavitation tunnel. And then they built actually together with ITU, the large cavitation tunnel. And also he came along when we designed together Newcastle University research vessel with another legend colleague. We also lost him, unfortunately, Professor Muhittin Söylemez. And then these two great colleagues. Mustafa was very important Gators project. I'll tell you why. Mustafa, actually, this project at the start may collapse because one of our colleagues had to pull out from the project because their ship had to be sold. By the time this project would collapse, but Mustafa walked in and then saying that, look, Mehmet Hoca, don't worry about that, we will find. And then he brought in the point, Çapa Denizcilik, and then this project is floating now. And this sketch here, actually, he worked on by individually. He sketched himself initial ideas. When we start to talk about, he said that don't worry. So therefore, I like to contribute and thank you to him and that he made this project valuable. That's all, colleague. Thank you very much. And then obviously I'd like to thank on behalf of all my Gators consortium. And Ahmet, thank you very much for providing this opportunity for me and to sort of talk about a little bit what we have been doing. That's all. I cannot hear you at the moment, Ahmet.
Thank you very much.
Okay, yes, I can hear you
with your
now.
speed and dynamism, I would like to summarize that an amazing collaboration created. I think this study environment, efficient study, efficient research, and innovation environment. I hope the maritime sector can or are able to establish, able to build such large innovative projects. I hope Gate Radar with the maneuvering and ship propulsion, as you stated, there are plenty of efficiencies. Several research studies we see. With the experimental work, we are able to also collaborate. I think in the afternoon we will speak on this. Thank you very much again. I am very sorry if Carlos, Professor Suarez, if you spoke a little less, I don't know. Sorry about it. Please, for Professor Mehmet Atlar, how can I show? We have.
Ahmet, I can see that. Thank you very much indeed. I appreciate very much your courtesy, and I will take that with pleasure on behalf of my colleagues in the Gators project, as well as on behalf of my colleagues in Stadtgleich University. Thank you very much indeed. I appreciate this very much. It was my pleasure. It was my pleasure to make this speech and to the Turkish maritime industry too.
It was our honor to listen you. Thank you very much. Thank you. Buradan konuşabilir miyim?
I can hear you, Ahmet. Thank you.
Professor Atlar, there is here Captain Salih Zeki Çakır, our Deans Hüseyin Yılmaz, and Salim Söğüt, President of the Turkish Chamber of Naval Architects and Marine Engineers, Salih Bostancı, Başaran Bayrak, and also Feramuz Aşkın. He's also the president of the chamber.
It's great pleasure to see them and all, and I'm very pleased that I can tell something about the project and that's my great pleasure. Thank you all very much.
Professor Suarez, we would like to, with the all colleagues and maritime stakeholders, we would like to thank you. I'm expressing their thanks. We are very honored to listen to you. During my first speech, I have forgotten two collaborating universities, which was Karadeniz Technical University in Trabzon, and the other one is Dokuz Eylül University in Izmir. So I added this. These are in the organizing committee. There were members from those universities. Have you any question? I have forgotten it. If not, for the Professor Atlar, if gate rudder can be applied to the twin propeller ships.
To be perfectly honest, this is a very interesting and concept. In theory, yes, it can be applied. But in practice, we also have some interesting ideas too, like converting a twin ship to a single ship by using the gate rudder's advantages. In theory, yes, it can be applied. And also we are actually on a research level, we are looking into it. So my answer will be, in theory, yes, we can apply. In practice, at the moment, we have to demonstrate. So that's my answer.
Thank you very much. He's saying, yeah.
You're welcome.
Please, Mr. Ömür Karataş asks a question.
Sure.
I think you applied gate rudders to two rail ships, I think. He's asking the number of ships applied.
Sure. At the moment, 3 vessels are in the water operating with gate rudder. But they are all new built vessels. This will be the first time as a retrofit to be applied to a box standard vessel. So there are also 2 ships are being built at the moment. They will be in the water 2022, but they are also 2 new vessels. One is a training ship, another one is a largest coastal container vessel. So size are getting bigger.
No more question. The time is limited because of the remote connections. The time is very limited relative to the past conferences. This period is that. So we would like to, I think we conclude the opening session of the Congress. Thank you all. We conclude.
Thank you. And also my best regards to Carlos as well. Carlos, very nice to see you, and thank you for the presentation. Okay, thank you.
Ahmet hocamıza çalışmalarından dolayı bir plaket takdim etmek istedik. Ekibiniz adına. Teşekkür ediyoruz kendisine.
Evet efendim, yapacağım. Bunu şöyle yapacağım. Alırız biz onu. Şuraya koparız. Hocam şöyle.
Buradan şu anda yemeğimiz hazır. Müsait olanlara bir yemek.
Recording.